In this example, if an amount p sub 0 is invested in a savings account and interest is compounded continuously at 4.3% per year, the balance p grows at a rate given by the derivative of p with respect to t is equal to 0.043 times p. For part A, we want to find the function that satisfies the equation. Write it in terms of p sub 0 and 0.043. Since the derivative of p is equal to a constant times the function p, we know that the equation for the function p has to be an exponential function. So we need to come up with an equation that looks like p sub t equal to p sub 0 e to the k t, where p sub 0 is our initial and k is our growth rate. We are not given an initial population in this case. We are, however, given a growth rate, and that is the 0.043. That is k. So we're going to plug that in for k, and we're going to have p sub t equal to p sub 0 e to the 0.043 times t. And there's our function. For part B, suppose $20,000 is invested. What is the balance after 1 year? And then what is the balance after 2 years? So here, we're supposing that $20,000 is invested. So that is our initial population. So we're going to plug that into our equation. So we're going to have p sub t equal to 20,000 e to the 0.043 t. Next, we want to know what is the balance after 1 year, and then what is the balance after 2 years. Well, after 1 year, that would be when t equals 1. So we're going to plug 1 in for t, so we have p of 1 is equal to 20,000 times e to the 0.0431 times 1. And then when we evaluate that in our calculator, we're going to get approximately $20,878.76 when we round to the nearest cent. Now we're going to do the same thing at time t equal 2 to find out the balance after 2 years. So p of 2 then is equal to 20,000 times e to the 0.043 times 2. And then when we evaluate that in our calculator, we get approximately $21,796.13 rounded to the nearest cent. Alright, so that would be the balance after 2 years. For part C, when will an investment of $20,000 double itself? So we want to know the doubling time. So here we know that doubling time t is equal to the natural log of 2 divided by k, where k is the growth rate. So in this case, we have natural log of 2 divided by a growth rate of 0.043. And if we approximate that, we get 16.1 if we round to the nearest tenths place. So after 16.1 years, the investment will have doubled.